just when you thought it was going to be a normal Monday.
Baby math, 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 baby math.
All right, baby Nyson, what do you want to be when you grow up?
I want to be a math teacher with the world's best students.
Are you good at math?
Mm-hmm.
Well then, what is the quadratic formula?
X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a.
What is 99 squared?
9,801.
Can you recite pi?
Yes. 3.14, Does that make me a cutie pie?
Whoa, it's good to be back to one's own self. You know, when I was young, I wanted to grow up and be an astronaut. But my dad would always say, son, the sky's the limit. So I guess I couldn't be an astronaut. So I became a math teacher. No, really, I could never be an astronaut because I suffer from acrophobia. I'm acrophobic. Acrophobia is the fear of heights. Well, maybe I don't have a fear of heights. Maybe I just have a fear of falling. You know, many people have told me, Mr. Nyson, if you could overcome your fear of heights, you'd be very influential. And I agree with them. I would have a great impact. But make sure you pick the attendance. It is Monday, May 18th. Make sure you get that attendance taken today and every day. And so welcome back. This is your e-learning store for this week. This will be our last week of warm-ups. This will be the last week for Khan Academy. And so if you get these 3 done, you're done. And so get them all finished up, get all that done. And so that's going to be this week. Also, we have logic problems this week. Next week, we only have 2 days to school. And so we're wrapping things up. And so you want to also be wrapping things up and get this extra credit done. Also, I haven't really been, I'm going to try this week to make it to Mrs. Wagner's lunches. And so if you want to show up, I've never been there before. Maybe some of you haven't been there either. And so it'll be good to maybe see everybody. And then also next week, the school has certain days and your parents will get all that information about when to pick up stuff that was in your locker. But it's not just about pick up. It's also about drop off. And you have a textbook of mine and some of you have some other things. In geometry, you have mirrors and compasses and I want the stuff back. And I might have some things to give to you. And so we'll let you know about that more. But next week, we're going to plan on being at the school for those 3 days. And they have it all alphabetized and things. And so even if you don't have anything to pick up because your locker's all cleaned out, you do have textbooks, maybe library books, and things of mine that we need back. And so just listen. Whatever the school says takes priority. But you can email me. But we do want to get some of our things back. And that will be next week, and it'll be good to see some of you one last time before the summer, okay? And so, but this is the beginning of the week, and we want to do logic problems also. Some of you signed up for that math contest. You can still check the link I sent at the end of last week, but it costs $15. It's a math count style competition. It's Wednesday, I think 4 to 7. You have to be proctored. There's a lot of specific things, but also you need to make sure that you were supposed to sign up for that maybe by yesterday. And so you can double check to see if that window's still open in case you forgot. But he who hesitates is lost. So don't put things off, especially in this time of being home. It's easy to put things off. Okay. So for logic problems this week, we have some of you like these. Everybody got these right. And they were 3 darts last time. And so this time we got 5 darts. Just don't be throwing the darts at me. Okay. And so if you have this, you want to pick 5 numbers that add up to 111. It's a little tougher when there's more of them. But you could, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. You can either figure out which 5 add up, or you could add them all up and then subtract what you don't need, as opposed to keeping track of what you do need. And so that's another way of thinking about it. This second one could be kind of tough. It says determine the number of squares of any size that contain exactly one odd number. And it doesn't matter if there's an even or not in it. It just matters if there's an odd. And I got to shrink myself down so we can see more of this stuff. Okay? So if we look at this, determine the number of squares of any size that contain exactly one odd number. And so the first question is, and you got 3 of them to do. So like this one right here is in how many squares? Well, it's in this square. That counts as 1. It's in this square. That counts as 2. It's in this square. It counts as 3. It's in this square. It counts as 4. It's in this square. Now that has an even, but it only has one odd number. That counts as 5. But if I include this square, that would have 2 odd numbers, and I can't do that. Now what you have to do is you have to do that for all these odd numbers. Like here's 1. Here's 2. But I can't do 3 because I would have 2 odd numbers. And so I'm counting how many squares have only one odd number in it. They can have an even. Then the question says, how many squares have exactly one even number in it? And that means it can have an odd. And so this one's in 1. It's in 2. It's in 3. It's in 4. Do the 2 by 2s. Then do the 3 by 3s. Well, you can't do this one because that would have 2 evens. And then you'd have to have this one. And then you'd have this one. And so, and then the third question states, how many, whoa, I got shrunk. No, not back to the little kid, no. And so, get the sound off my face. It says, determine the number of squares any size in the diagram that contain exactly one even and one odd. So you only can have one of each. And so, like this would have one of each. But then, that's an even and an odd. This one would have one of each. This one would have one of each. Okay? This one would have one of each. This one would have one of each. This one would have one of each. I think you're getting the idea. And you want to get the maximum. And the counting problems, I know some of you is like, this is not my favorite. I need to grow up a little. And so here we're back. And then on the backside, some of you have emailed me and said, Mr. Nyson, with no tests and quizzes, I don't get say what you sees. And Preston, I don't like say what you sees. It's okay, Preston. You can still do them. And so I thought we'd give you some for one last time this year, since we don't have any on the tests and quizzes. But we'll shrink this down. Not me. Whoa, what's happening? And so this says there are a bunch of problems at the bottom, and you need to find, I don't know what's happening today. Shrinking down, getting bigger, kind of strange. I'll put myself right here. And so you have to write all the say what you sees down here at the bottom. So the letter tells you how many letters are in the word. If it says 4-4, that's 2 4-letter words. Okay? If it says 10, that's a 10-letter word. And if you think over, under, on, you're going to get most of them. And the reason there's a word search is because maybe you could find the word up here, like I see the word coupons. Well, that's a 7-letter word. And these down here are in alphabetical order. See, I'm making it nice on you. Oh, that'd be this one. And I'm going to write it here. C-O upon S. And so that would be coupons. If I write right here, ab on. Oh, ab and on. And so that would be abandon. Now, can I find the word abandon up here? I want you to find them both places. And so they could be backwards, they could be reversed, they could be wherever. I don't know where abandon is. Ab, oh, here it is. Ab and on, abandon. Okay, so the word search is supposed to, you just like look and go, wait, I found a word, cloverleaf. I wonder where that is. I found campground. I found belittled. I found a by a small y, and that would be abysmally. And so you know the next one's going to begin with A, these are going to begin with B, This one's going to be campground because camp G, round, campground. And so you look through those, and even if you maybe say, I don't like say what you see, I'm telling you how many letters, I'm telling you they're in alphabetical order, and I'm showing you all the answers up here that you can just find them. Okay, so I know some of you have been missing those. And so work on those, get both sides done. This week might be worth more than 10 points and make up for having maybe being the last logic problems of the year. And so we might have something for you next week, but it won't be logic problems. And so, but we'll be wrapping things up. So these will probably be worth more than 10. And so you want to get them done, and that's a way to raise your grade. Okay? So logic problems, warm-ups, and now let's get to the notes. Let's see what's in store for pre-algebra today. We are shifting gears. We're going to the last thing we're going to cover this year. So we spent time. Normally we'd have a review game, we'd have a test, we'd discuss functions. We would have even had a quiz over graphing straight lines. Then we would have had a test over the parabolas and the y equals mx plus b and finding slope and all these things that we did. Well, you missed all that. And so maybe you're glad to miss the tests and quizzes, but you still need to know the things. And so the very last thing we're going to discuss this year, the topics, and we are going to have assignments every day, even next week. When some people go, well, they said there would be no more homework. I'm telling you right now, we have assignments, and they're going to be due, and they're not due Sunday night because school's out on Thursday. And so we're going to be done on Thursday, and you're going to have to work and turn it in. And we're going to see who doesn't do that. But we're going to have something every single day. What would you expect? And that's what we're going to do, okay? And so we're going to talk about the counting principle today, and we'll post the video here when we're done, and there's a worksheet. So we have notes, and then we have the worksheet. And so we're going to go straight to it. And so what we're going to do today is talk about how many choices there are for things. And so in order to do that, we're going to go to a different website and kind of do this little activity. I just went to this Illuminations website that we've done some things on before, and there's this activity. It's like, how many outfits can you make for this teddy bear if you had 2 choices of overalls, maybe some hee-haw overalls, and 3 t-shirts? And you'd be like, okay,
make as many different outfits as you can.
Oh, the computer's talking to me. So you could have blue overalls with blue shirt.
I like that color combination.
You could have blue overalls with a green t-shirt.
I like that color.
You could have blue overalls with a red t-shirt.
I like that color.
Could we have any more with that? No. We could have green overalls with a blue t-shirt. We could have green overalls, with a green t-shirt. He looks like Mr. Green Jeans. And no, he was on Captain Kangaroo. And then green overalls with a red outfit.
You've made all of the outfits.
Oh, I made 6 of them. Yay!
Daddy Bear can now be the most stylish bear in town.
And it's still talking to me. And so the thing is, on tonight's homework, we want to talk about the counting principles. How many different combinations of things can you have? But the fact of the matter is, we don't want to write them all out. And so if I had 2 pair of overalls and 3 t-shirts, what would we do with a 2 and a 3 to make a 6? What's that, John? Yeah, we'd multiply them. So the counting principle has to do with multiplying a bunch of numbers together. And so you're going to see that on Khan Academy as one of the warm-ups, the counting principle. You're multiplying numbers together. And we're going to see that today on the notes. And so today's notes, when we talk about the counting principle, this is notes number 127. So we want to write that down. And if we were in class, we'd give you a chance to win some money. And all you have to do is pick the same 5-digit number as me. And if you do, you'd win 20 bucks. Okay? So I got $20 right here. I'll just hand it to you through the screen. Here, you take it. Oh, give me my money back. Don't keep taking my money. And so 20 bucks is yours if you can match the number that I write down. And so I'm going to write down a 5-digit number and see if you can write the same one down. Okay? You ready? Don't be matching mine, because you almost took my money as it was. Are you ready? Write your number down. No cheating now. Okay? Show me your number first. Well, here's the number. Whoa. Did you write 41972? If you did, you win 20 bucks. Yeah, I see you changing it. What are you doing? You got to be honest. And so, what was the chance that you were going to write the same number as me? You know, I say I'm going to give 20 bucks back. Well, don't be taking my money. Oh. And so, but I don't really give it away because I know the chance of you winning is possible, but it is not probable. And so if we have a 5-digit number, today we are going to draw 5 blanks. And the question is, how many choices is that? Well, if you could pick anything from 0 to 9 for this number, not 1 to 9, but 0 to 9, how many choices would that be? Jack? Yeah, it'd be 10 choices. There would be 10 choices for this number. You have a 1 in 10 chance of just picking the 4. I could have been mean and went 0, 0, 0, 0, 0, or something crazy like some people would pick. What's the chance that you'd pick the second number? Well, you could pick 0 to 9. Now, if I said they couldn't be repeated, or if I said they had to be odd, or if I said they had to be even, but if I just say it's any old number, that's 10 again. And if the third number, you only have a 1 in 10 chance of getting the third number. But when we put them all in combination, well, you have a 1 in 10 chance of getting this tens place right. You have a 1 in 10 chance of getting the ones place right. But the thing is, what would we do with all these tens? We would multiply them. You have a 1 in 100 chance because you could pick any number from 0, 0 to 99. You have a 1 in 1,000 chance because you could pick anything from 0, 0, 0 to 999, which is 1,000 numbers. You'd have anything from 0, 0, 0, 0 to 10,000. You'd have everything from 0, 0, 0 to, or this would be 10,000. That'd be 9,999. That'd be 10,000. And so we have here 5 zeros, which is 100,000. How many choices of numbers are there? You have a 1 in 100,000 chance. Yeah, but we all won. What's the likelihood of that? Possible, but not probable. And so, oh yeah, we all got it. I'm emailing you, Mr. Nyson, 41972. And so we matched. On this next example, how many possible combinations are there if every digit has to be different? Now, my answer, every digit was different. I didn't tell you that, but if I did, how many possibilities is that now? Well, how many choices would we have for the first one, Gloria? Yeah, we'd have 10. And then if the first number can't match the second one, you can't pick the same, then how many would that be, Joseph? Yeah, it'd be 9. Then how many would the next one be? It'd be 8. Then how many would the next one be? It'd be 7. Then how many would the next one be? It'd be 6. Now there are ways we're going to talk about this as the week goes on. Oh, this is 10 pick 5. It's a permutation, Mr. Nyson. But right now you just type in 10 times 9 times 8 times 7 times 6. And you should get 30,240. Well, that would be a huge hint. We went from having 100,000 possibilities to now I only have a 1 in 30,240 chance. You increased my chances 3 times. Well, that's good. What about this next one? See, on your homework tonight, I want to see you to write blanks. If you're picking 5 things, I want 5 blanks. If you're picking 2 things, I want 2 blanks. How many possibilities if the first digit can't be a 0? Well, then there's 9 choices. The last digit has to be even. From 0 to 9, how many evens are there, Josiah? 4? No, 5. 0, 2, 4, 6, 8. There's 10 numbers. 5 are odd, 5 are even. And so there's 5 even digits. Well, the other 3 can be whatever they want, so we put 10s. And so 9 times 10 times 10 times 10 times 5, 10 times 10 times 10 is 1,000, 45 times 1,000 is 45,000. So it's actually a better hint that I said all my numbers were different than it is to say it's an even and it doesn't begin with a 0. Because that would only give you a 1 in 45,000 chance. But Mr. Nyson, we all got it. So, because we cheated. And so when we come to figure out how safe we are. So remember your old locker combination? Do you still remember it? Could you open it? Well, you won't be allowed to go in. They got all your stuff in a bag waiting for you. With a big old sticker on it. Labeled. And so, but remember when we did have a locker combination, it had how many numbers, Tucker? Yeah, it had 3 of them. And so all these are going to have 3 numbers, just 3 numbers. And how many numbers are from 0 to 49? Is that 49 numbers, Thomas? Yeah, it's 50 numbers. Good job. So how many total combinations are there? Well, 50 choices for the first, 50 choices for the second, and 50 choices for the third. And that is not 150. 5 times 5 times 5, 5 cubed, 125. 3 zeros, 125,000. You think someone would notice if you're staying outside somebody's locker trying all 125,000 combinations before they said, Brody, what you doing? Safe enough. Yes, there's a chance you could guess it, but it is possible, but it is not probable. But you know, I know none of you have locker combinations where all 3 numbers are the same. In fact, I have never met a student at our school that had even 2 numbers the same. Most of the time, they're all different. I don't know why they do that. They just make them all different. So the first choice would be 50. The second choice would be 49. And the third choice would be 48. And so it'd be 50 times 49 times 48. And so that would be 117,600. And as long as we don't have 117,600 lockers, all of you get a different combination. And do you know they go through the school and they change all the locks every single year? That takes a tremendous amount of time. And so, because many of you have different lockers each year. And then the third one, how many total possibilities? To me, Mr. Nice, it's been so long since I opened my locker, I've been home all this time. But see, you know it. So how many choices? My first number is like 13. Well, you don't put a 13 here, because that would mean you had 13 choices. You'd only have 1 choice, because you know it. Hey, it's a 13. Well, then I choose 13. But I don't know the second 2, but all 3 are different. Well, then it would just be 49 times 48. I have 1 choice, then I pick 49 different numbers. Actually, on a lock, as long as you're close, it's like within 1. You don't really have 50 different numbers. You have like 50 divided by 2 or 3. You have about 20 different numbers, because all you got to do is be close. And so, but that's okay. And then 49 times 48 is 2,352. And so even knowing 1 number increases the likelihood of someone knowing the whole thing. Okay? And so then with computer passwords, especially Microsoft things and games, one game that I always liked to play with the children when everybody was home was Age of Empires. And they always had these huge long passwords. Well, the thing is, when we make passwords, most of us just use capital letters and lowercase letters and things like that. But these are all the things. There are 26 letters of the alphabet. If lowercase are different than uppercase, that makes 52 possibilities as opposed to just 26. Then you add the 10 digits. Well, then you're up to 62. And then you add all these other symbols. And then there's actually, they call it the ASCII 2 text. There's 95 different characters you could use. And most of us don't use the % sign and the $sign. Maybe you do, but you know. All these different, greater than, less than. Maybe you make a smiley face in your passwords. Who knows? But someone said you need a 7-digit character, case-sensitive password. How many could you have? Well, we want to draw 7 blanks. And so it'd be 1, 2, 3, 4, 5, 6, 7. And what would go in each of these blanks? Well, it would be a 95. And I see the sounds on my face. And so we want to put a 95 in all these. 95 times 95 times 95 times 95 times 95 times 95 times 95. But it's much faster here to write 95 times 7 or 95 to the 7th. Which one would it be, Ainsley? 95 to the 7th power, we would get 6.98. Oh, it'd just be 6 choices. No, see, that's in scientific notation. Times 10 to the 13th. And we're just going to round the decimal off. 7 times 10 to the 13th. Well, 3 is 1,000, 6 is 1,000,000, 9 is 1,000,000,000, 12 is 1,000,000,000,000. That's how much money the government's spending all the time. And so to help out with this Corona stuff. But this is over this 10 to the 13th. And that's how many choices there are for passwords. How many 14 character? 95 times 95 to 95. It's not 95 times 14. This would be 95 to the 14th power. That's too many blanks to be writing out. And so I could just arrow up on my calculator, change the exponent to a 14. And this thing, look how many zeros there. 4.9 times 10 to the 27th. That means the decimal belongs 27 places to the right, That's a big old number. And then we got this password for an old Age of Empires game from Microsoft. How many digits long is that, Seth? 5, 10, 15? Yeah, it's 25. That's going to be my exponent. Now notice that the password's only using capital letters. How many letters is that? Yeah, it's 26. And if there's 10 digits, that's 10. And so 26 plus 10 is 36. And so for every one of these blanks, 36 choices, 36 choices, 36 choices, 36 choices, 36 choices, 36 choices. And we're adding or multiplying those. Lucas, yeah, we're multiplying them. This is 36 choices for every one of those blanks, and there's 25 blanks. 36 to the 25th power. You aren't guessing, but my friend gave me his Age of Empires game, and I thought it'd be fun. But I asked him if he had the password, and he said, no, you could probably guess it. Yeah. 8 times 10 to the 38th power. 8 with 38 zeros. You got a better chance of catching Corona from that. But I don't have it, and you don't have it probably, so you got a better chance than guessing that password, so you might as well. So I've been doing all break, just guessing passwords. Not going to happen. Plus, they lock you out after 3 tries, which is also crazy because 3 tries, you got a lot of tries there. Okay? So for the homework tonight, this is assignment 127. And the first problem is this is not your locker combination. This is a bike lock. And there's still 3. But on a bike lock, if you look at the picture, it's 0 to 39. It's not 0 to 49. So it's not as secure, but it's secure enough. Plus, someone could just cut the chain. And your lock could be secure, but your chain isn't. So 0 to 39 is 40 choices. And so you have 40 choices times how many? If they don't repeat, you start with 40. And you don't do 40, 39, 38. Here, how many total possibilities? You know the first number? 1. But the other 2 have to be different. 39 times 38. Then this is like the teddy bear problem. You have 6 shirts. You have 5 ties. This is also like the warm-ups on Khan Academy. You just write a 6 and a 5 and you multiply them together. You know what to fill in. Number 8. For each of the 8 colors, I have 1 shirt and 1 tie. So I have a shirt blank and a tie blank. And do I put an 8 in each box? If I refuse to wear a white shirt with a white tie, or a blue shirt with a blue tie, would it be 8-8 or would it go 8-7? How many license plates could you make if you have 2 letters followed by 3 numbers? And so how many letters of the alphabet? Brody? Yeah, 26 times 26. How many numbers are there, Layla? 10 times 10 times 10 times 10. But how if you had 3 letters followed by 2 even digits, followed by 2 odd digits, and you're multiplying them all together? How many ways can I put 5 books on a shelf? 1, 2, 3, 4, 5. When you stack 1, it goes 5. And then do you have 5 still to put on the shelf? No, then you have 4, and then so on. How about if you have 6 on a shelf? You start with 6, and you work your way down. Then for the last ones, how many ways can you form a commission if you have a European country, an Asian country, a North American country, and an African country? You just write the numbers in. It's kind of like, oh, got the sound back on my face. Whoa, get that off of there. Here we go. Whoa, there you go. Now, Your math club has 20 members. You want to pick a president, you want to pick a vice president, and you want to pick a treasurer. And you can't be all three. You only can pick one. So you got 20 choices. Then after you pick that person, you only have how many choices? Here, you got first, second, and third place. You got 8 runners. Well, any of the 8 can win first. Then after you pick one, how many are left? And then this last one, you have 6 different books. I want to see 6 blanks on your paper. Okay? And it says 2 of which are different. Here, we'll move myself up here. 2 of them are math books, and the math books have to be at the end. So this is a math book, and this is a math book, and I only have 2 math books. So I only have 2 choices, and then after I put one, then how many choices do I have for this one? Then for these blanks, how many books are left? Are there 6 books left? And then it goes down from there. And so we try to keep it all orderly. Okay? So get all that done. Send that to me. Hopefully, I'll try to make it to one of Mrs. Wagner's lunches, the 6th grade one. And so many of you, maybe you haven't been there either. And so it'll be good to see all of you. We'll try to fit that in. And then remember, next week, we want textbooks back. And so you'll get more information. Of course, the school will be sending information to you. And we'll see what they all have to say. Okay? So hopefully, everybody's having a great Monday, probably staying in. Get the e-learning done if it's raining all day. And so get your warm-ups done. There is one on permutations and combinations, which we're doing on Wednesday and Friday. So some of you get those done. Maybe I should have you teach Wednesday and Friday. Okay? So, but everybody have a great day. We miss all of you. Keep up the good work. Give me everything. It's wrapping up. Okay? Bye-bye.